I just want to say welcome all of you into this workshop of Autodesk Fusion 360. In this workshop, we will learn water tank 3D modeling that you can already see on the poster on your screen as well. So this is the water tank that you can see. It's a plastic water tank that we normally used to see in our homes. So this is what we are going to model today inside Fusion 360. And since it's not a very complex model, it's a simple model. So we will learn the basics also, like how we can do something in Fusion 360. And we are not going to talk about the very basics like the user interface and all those other stuff because those things we had already discussed in our earlier workshop. So if you had not watched my earlier workshop, you can check those workshops on my YouTube channel. I had already posted the recording of my older workshop onto my YouTube channel, and the same you can also find in the group chat right now. So if you will just check out our Zoom group chat, you will able to see my YouTube channel link. So as you can see on your screen, this is the tank that we are going to model today. So let's move on to the agenda for this workshop. As you can see, we'll go through the quick introduction of Autodesk Fusion 360, like what, how, and why we are using Fusion 360 for this modeling. And then we'll learn about little bit about the calculation, like how we can calculate and decide the diameter and height for our water tank model. And after that, once we are done with deciding the height, diameter, and the other stuff, once we had confirmed the volume of our water tank, then we will move on to designing that tank inside Fusion 360. And at the end, we'll talk about some free and paid resources. From there, you can start learning Fusion 360 software. So those things we are also going to discuss. And at the end, when we are done with all this agenda, our workshop agenda, at the end, I will introduce you uh, about myself, like who I am and what I do for my living. So so let's move on to the our first topic, like why Fusion 360, why I had selected Fusion 360 for this workshop. And the first reason is guys, it's since it's a cloud-based software, as you can see, it's a cloud-based software. So when we say cloud-based, this means it's easy to run onto your PC. You don't need a very expensive hardware, very advanced hardware to run this software. You can run this software even on your normal PC, normal computer, because it's a cloud based. And when something is cloud based means a very large portion of it is running on the internet, and a small amount of installation is being done onto your local PC. So that's why it's a cloud based software. And this is the reason I am recommending this software to all the students to get started into the design industry. Next, it's free for students and educators. So if you have the student ID, if you are enrolled in any college, and then you can activate this software for free for 1 year with 100% full features. There is nothing like on a student version you are going to get something less. You will get the full access to every feature inside the software if you will subscribe using your student ID. And also for the educators, like the teachers or the professors, those people can also get this software for free for 1 year. Okay, now the next thing, guys, it's easy to install. It will just take maximum 20 half an hour to 1 hour to install this software, even lesser. It depends upon your internet connection, because I told you it's a cloud-based software, so you had to be connected with the internet all the time whenever you are using this piece of software. So during installation, you had to have access of internet. So it's easy to install. You will be able to do quick installation if your internet connection is good enough, because these days all the people have good internet connection. And the next thing I already discussed, it can run onto the normal hardware as well, because you can run this software onto your i3 processor or i5 processor, or even on some uh, lower version of AMD processors, I will say. So you will not need a very high-end softwares and configuration to run this software. So you can try this software. If you are a student, you can get the license. Also, if you are not a student, you will get 30 days free license, trial license as well. Now let's move on to our next slide. So how you can download this software? So it's easy. Just visit the Autodesk official website. It's available on. It's the Autodesk product, guys. I just forgot to tell about this. It's the Autodesk product, and the same product, the same company that has created AutoCAD, the same company that has created Autodesk Inventor, the same company has created Fusion 360. So Fusion 360 is their future product, cloud-based product. So you can download this software onto the official website of Autodesk. Simply create an account, like any other social media. You just need to sign up. You need to fill up few of the details and you will get your account. And whenever you will download and install Fusion 360, you just need to log in into Fusion 360 using that username and password that you had used to create your account onto the Autodesk website. So it's easy, it's simple, and you will get full access to the software. Now, since I told you we'll talk about quick introduction of Fusion 360. So this was the basic introduction of Fusion 360, why we had selected this software. Now let's move on to the calculation. And before moving on to the calculation, uh, as you can see, we since we had just started this workshop, I just want to give it a quick look of you to all of you to about Fusion 360. So here you can see. Right now on my screen, this is Fusion 360. So whenever you will first install this piece of software onto your PC, this is the screen you are going to get. So this is Fusion 360 default UI, guys. Default UI, when I say default UI means this is the screen you will be getting whenever you are installing and running this software for the first time into your PC. So as you can see, on the top, it says Autodesk Fusion 360 with its logo, definitely. And on the right side, there are a few things like my account from where I had logged in. Since you can see, I got an option to sign out as well because I'm already signed in right now into this software using my ID and password. So if I will sign out, I can access the same content, same thing onto any of the computer across the globe. So if I want to access my designs, if I want to access my any of my drawings or any of my product designs, I can access anywhere on any computer. I just need to set up and install Fusion 360 onto that PC, and I just need to log in using my Autodesk account, and I will get access to all my files, folders, and everything that I had created inside Fusion 360. Since it's cloud based, all the content is getting saved on the internet in the cloud, the space that is being provided by Autodesk. And again, guys, I had heard that many people are keep saying that your content is not safe. So that is not the case. Autodesk has very good vault system. They used to secure your content, whatever the designs you are creating, whether it's your personal or uh, proprietary content, it will be completely safe in the Autodesk cloud space. So you don't need to worry about like it will get leaked or it will get someone else will get access to those contents. It's not possible. It's only accessible by you using your ID and your password. So here you can see this is the default screen of Fusion 360, and on the left side, when I will click on these icons, it says show data panel. So here you can see this is my data panel where all my folders, all my files are saved over here. So if I go into the home view, here you can see I had created different projects where I used to save all my files and folders inside this project. So I got three different kind of projects. For example, if I will just go into the Fusion 360 Workshop project, here you can see inside there we got some folders, few designs already saved. So again, if I will go into the other projects, we got multiple design and multiple folders created, and the projects and all the stuff that I am working on or that I had worked in the past is getting saved onto this data panel. So whatever the designs you are creating is automatically getting saved inside the cloud, inside your cloud space. Also, you can save it on your local computer and PC. That's also possible. Uh, like for example, if you are working in SolidWorks, you can save your parts assemblies as SLD part file or SLD ASM file. So in the similar manner, in Fusion 360, whatever the designs you are creating or working, you can save it as a .f3d file format. So that is the default file format for Fusion 360 that you can do. So as you can see right now, we got different folders, different projects. So if I will just go on to this YouTube project folder, here you can see these are some of the projects I did work for my YouTube content. Here you can see you will be able to see small preview as well for your designs. For example, if I try to open this design that I had worked on last year, as you can see, the date is also visible over here. So if I will just make a right click and click on open, also what I can do, I can just double click on any of the file to open it. So if I will just double click on it, it will just take fraction of seconds. I told you, based on your internet speed, it will take fraction of seconds and it will be uh, visible onto my Fusion 360 screen. Now, if I will close this data panel, so when I say close this data panel, I mean to say hide your data panel. So here you can see this is the design that I had opened. So if I try to rotate it to see it from different angles, I can do that. Here you can see it's simple design, just a small visualization texture applied on it. That's why it's looking like so much bright parts, but it's a simple plastic part that I created for my project. And it is just a few minutes of project that such kind of projects you can just do in few minutes. So this is what we can do inside Fusion 360. And again, if I will go on to my data panel, for example, if I will open this 3D printable thread, so I was testing out some tolerance of my 3D printer for the threads. So for that purpose, I had created this model. And here you can see this is the 3D printable thread that I had created. So I told you it was just for a purpose. I wanted to test the tolerance of my 3D printer, my materials. So that's why I did this model. And right now you can see it on the screen. So this thing you can, this such kind of projects you can create inside Fusion 360. These are just simpler projects. People are doing very complex project, very practical projects also inside Fusion 360. So it's completely onto you. If you have any idea and if you want to convert that to a real project, then just explore this software. Now, as I had told you, now again, if when you are done with your design, you can just click on this close icon and it will just go back into your data panel. Getting back saved onto your data panel. Since I did not make any changes onto those two designs, so they are still on the earlier version already. So now move on to our agenda for the thing. Now we are going to learn, first thing that we are going to do, learn about the water tank design calculation. So for that I had created a slide over here that you can see. This is the slide. So let me just bring it on full screen. Okay. So this is the tank that we are going to replicate inside Autodesk Fusion 360. We are not going to create the cover part, but we're going to create the base part. That is the full tank design we're going to do. And now, as you can see, it's a tank from the Syntax company, but this is just for a reference that we're going to take and how the tanks are designed. So these tanks are basically, I will say, molded products. These tanks are manufactured using molding, but the design is being created in any of the softwares. I'm not sure the company has followed what process or what software, but it is being designed in any of the CAD software. Then they had taken those files, those dimensions, and based on that, they had created mold, and then they had created this product. So as you can see, for this workshop, I'm going to take this standard water tank volume. So a standard water tank volume at our homes is 1,000 liters all the time. A max of the time we used to install 1,000 liter of tank into our homes. There you can see this is our tank, 1,000 liter tank. And for 1,000 liter tanks, if you will check on the website, if you will check on the internet, Syntax has considered diameter of 43.3 inches. So if you will just convert that to a millimeter by multiplying it by 25.4, that is inches to millimeter. So you will get 1100 millimeter diameter. So diameter for this tank is 1100 millimeter, right? And now if we'll talk about the radius, it's definitely the half of the diameter, that is 550 millimeter, right? So if will diameter is 1100, radius will be 550, half of that. Next, the net height. So here you can see the net height is the height from the bottom to the top up to this flat portion over here. So the net height, the Syntax recommend text consider for 1,000 liter tank is 48.2 inches. So again, if you'll convert that to millimeter, that will come around 1225 millimeter. So net height is from bottom to the top flat area over here. Now the effective height. So when I say effective height means from bottom to this area over here up to the throat of your tank. So if that is called effective height, and the effective height, if you will calculate, it will come around this much, 1050. But the company does not specify the effective height. Effective height is based on the volume of your tank. If it's a 1,000 liter tank, and if you want to store 1,000 liter of water inside this tank, you have to take effective height of 1050 millimeter. When I say effective height, I mean the effective volume up to this area only, up to the throat. Now, how you can calculate the volume for this particular tank? Since from the company data, from the company's tank specification, I got the diameter and the net height. So based on that, if you want to calculate the volume, so the calculation for volume is pi r square h, where pi, the pi is a constant, a mathematical constant. So value for pi is 3.14 all the time. Also, if you want to write it in a fractional manner, it's 22/7. So here you can see V equal to pi r square h is the formula to create the volume for this particular tank. And we know the pi is 3.14. We also know the r radius. The radius is, I already told you, it's 550. And h is the effective height, guys. So h is the effective height, right? So here you can see, if I will calculate the tank value, I had taken pi, then I had taken radius 2 times, then it's the radius square is over here. So I mean r into r, that is 550 by 550, then 1225. Here I had not taken the effective height because I'm considering the volume of the full tank, and that is completely wrong. I need to change it over here. So that will come around 1050 mm. So I will just change that to 1050 mm. Here you can see. So if I will change that to 1050 mm, the volume will come around this much. Here you can see, and the liters will come around 1,000 liters. So this you can calculate on your end as well. You can verify it on your end as well, because this calculation, this is not accurate volume measurement, but it will be something near to around 1,000 liter. Since I'm not doing the calculation right now, but you got the formula, like how you can calculate the volume for the effective height, and from on the top portion over here, that we can consider, like we can design it accordingly, so the tank will able to sustain the load for if someone is coming over here for the cleaning of your tank, or for if someone wants to get inside, this area over here will able to take that load. So that is completely about analysis of your tank. So based on that, you can design the above part, but the bottom will be based on our calculation. So you can see we got the tank volume, and it's coming based on that. We are getting a height of 1050 up to this throat area over here. And again, the manhole diameter, manhole is the hole on the top from where we can access inside the tank. So that is also a standard thing, because manhole is common, is based on the ISO standard, and it's all the time for whatever is the equipment. Even if you are considering a pressure vessel, or even if you are considering some other kind of tanks, all the time you have to consider a manhole diameter of 400 millimeters. So if you will just convert that to inches, just give me a second, guys. Some people are asking for the link for this webinar, so I will just drop them the links for this webinars. Okay, so here you can see, as you can see, if you just want to go with the volume of the tank, I was talking about the manhole, sorry. So the manhole is all the time, it's 400 millimeter, because it's standard defined dimension by ISO for any kind of equipment. If the pressure vessel, if it's any kind of water tank, or even if any high pressure vessels like the boilers or anything, everywhere you have to consider a manhole of diameter 400 minimum. So that is the standard diameter for the manhole. So if any person wants to get inside for any kind of maintenance or cleaning purposes, so he or she will be easily able to get inside. So this is the basic thing. Now This is the tank that we are going to design. So we got the base diameter, that is 1100. We got the net height. We got the effective height, that is 1050. And so these are the things we needed for the modeling of this tank. And also you can see few ribs over here, this circular ribs, the circular ring kind of thing. So those are being provided to create the walls of the tank a little bit sturdy. Like if these ribs are not being provided, for example, if you had a plastic part with a very flat face, like we used to see in bottles. So if you will just try to press that, it will be easily, you can easily press that, you can easily deform it. But if the ribs are provided, it will add some extra strength to the wall of your bottles. In the similar manner for these tanks, for any circular profile, if you will provide the rib kind of shape onto the perimeter of your design, then that will add some extra strength to the wall of that particular object. And also on the top, these things are also provided. I told you it's for the strength of the top portion over here. If someone wants to get inside, he or she will be able to apply some load onto these areas. If someone wants to get inside, and the tank is designed in a manner so those it will able to sustain that load in that condition. So that is the effective goal. Now let's move on to our Fusion 360 and how we can easily create this tank. We will learn about that. So let's move on to Fusion 360. So whenever you are into Fusion 360 all the time, I suggest you the first thing to do inside Fusion 360 is save your file, the first thing. So I will just click on the save and then I will just go into the right project folder. So I told you I will just save into my Fusion 360 workshop folder, and here you can see the location just got selected. Then I will just give it a name. I will just write a simple name that so that I will be able to identify my design, water tank 1000 liter, right? It's simple name. And if I will just see over here, there is option called save. So I will just click on save option over here. And the moment I had clicked on save, here you can see it is getting saved. So guys, do not request to record this work. Do not request me to record this workshop since I am already recording this workshop, and you all will be getting a recorded session onto my YouTube channel as well. That the link for my YouTube channel you can find inside the chat box right now in the Zoom. So there I will be uploading the recorded session as well. Maybe after a few days when I am done with the editing, the basic editing. So right now you can see the first thing I told you, whenever you are inside Fusion 360, the first thing that you need to do is save your file. Now the next thing guys, the next very important thing is to check the document units. So if I will go on to the design tree over here, and again guys, if you want to learn the fundamentals of Fusion 360 that I had already explained into my older workshop that you can check onto my YouTube channel. There are lots of videos available that are related to the basics UI of Fusion 360, user interface of Fusion 360, so that you can check onto my YouTube channel. So right now you can see if I will just go on to my design browser here you can see there is a term called document setting, and if I will expand this option from over here, there you can say it says unit millimeter, right? So this is the unit that we are trying to model our tank right now. So if you want to change it, you can click on this icon, and the moment you will click on this icon, a new window will pop up like this. Here you can see where you can select different kind of units. So can you please comment in the chat box like what kind of system of units you used to prefer while working on the designs, whether it's millimeter, centimeter or inches? What's your preferred system of units, guys? Just comment in the chat box. My preferred system of units all the time is millimeter, since I'm from India and we do follow millimeter system of units here only most of the time. So I just want to know like what is your, okay, so I can see Joe Paul is commenting millimeter. That's really great. Millimeter is really handy since the inches and foot, those system of units are basically used by the used in the architectural industry, not in the product design industry, because here the parts are very accurate, very precise. So here we used to take millimeter most of the time, and the Thagat is also saying millimeter. That's really great. Selvan millimeter. That's great. Okay, so you can see we are right now we are on millimeter right now. So I will just cancel this one because I don't want to change this one. It's correct right now. Now, the first thing that we're going to create the base sketch for our tank that we had already discussed. So if you can see, the base sketch is definitely the circle with a diameter of 1100 millimeter, right? So I will just click on this create sketch icon over here, and then I had to select the plane. The moment I had clicked on the create sketch icon over here, I had to select a plane onto which I want to create my sketch. So that is the first thing. So I will select this top plane as a sketch plane. Apart from this, I also got two other planes like front plane and side plane. So it's completely onto you, but I will prefer this top plane right now for the sketch plane. So I will click on that. And here you can see the moment I had clicked, all my sketch tools just got activated that I was not able to see earlier. So the moment you will select plane, you will be able to see all your sketch tools. Now, here inside a sketch tool, if you will just come on to the create panel over here inside the sketch tool, the first thing is this center diameter circle. So this is what I want to create. So I will just activate this center circle diameter tool. Then I will specify the center. Then I will drag outside like this, and I will zoom out and will drag outside like this. I will zoom out, I will drag outside like this, and I will just try to estimate up to my diameter. So, and I will just click. So here you can see, this is the circle that I had just created, and the tool is still active. Here you can see inside my, with my cursor, the tool is still active. So I will just press escape on my keyboard to come out of the tool. And here you can see. Now I want this diameter of the circle to be, if I will check over here, it's 1100, right? So I will activate my sketch dimension tool now to define the diameter of this circle sketch that we had just created. So for that, what I will do, I will just activate my sketch dimension tool from over here. So I will just activate this, and then I will click on my sketch profile, and then I will drag outside like this, and I will write 1100 from my keyboard. Simply write 1100. I will just select all of the things and will erase that and will write 1100. Okay, 1100, and will press enter. There you can see. The moment I had clicked on press enter after providing the dimension, the measurements that I wanted to use, the sketch just got turned to black. And if I will just expand my sketch folder from here, here you can see it says this small red icon over here. This means that my sketch is fully defined. When I say fully defined means my sketch is fully constrained, right? I had provided all the specification, all the things to define this sketch that we had created. There you can see. Now, since we are done with the base sketch part that I already considered into our design calculation, now what I will do, I will just click on this finish the sketch option over here, right? And here you can, we are just came out of the sketch tool. Now we are back to our solid modeling tool. Here, I will just click on this home icon over here. So the view will just change to isometric view. There you can see it's isometric view. You can just zoom in or zoom out using your mouse or the trackpad, whatever you prefer. Now the next thing that we have to give it a height. We have to convert that to 3D, right? So what is the height that we want to go? So height is this effective height, and effective height is 1050, right? So I will just activate this extrude tool, will select the profile. Profile is already selected because that is the only single profile into my sketch right now. So the profile is already selected, as you can see, and I will just drag it towards upward, and I will just, if it's not taking the dimension automatically, I can write also with my keypad using numbers. So I had just written 1050 and will press enter. There you can see that I had created the base volume for our water tank, right? It was simple, it was easy. Now, the next portion that you can see over here is this net height. So now we have to work on the net height. So for that, what we're going to do is we're going to create a reference plane for that. So how we can create a reference plane for that? For example, if you will see over here, this cylindrical part has two planes, right? The top plane and the bottom plane, right? And now if I want to create another plane, another offset plane, another parallel plane, how we can do that? There is a panel inside Fusion 360 is called construct panel. So if I will go into the construct panel, there is an option called offset plane, right? From there we can offset plane. So if I will click on this offset plane tool, I just need to select the plane that I want to take as a reference to offset, and then I can specify the offset distance. So this distance, if you will just subtract from net height to effective height, so it will come around, if I will just subtract the net height to effective height, it will come around 125 plus 50. It's 175 millimeter, right? It's 175 millimeter, guys. So I will just write 175 millimeter over here. Boom. Here you can see I had written 175 and enter. And here you can see we have just created a new reference plane that is offset from the top of our cylindrical portion, right? Now, the next sketch that we are going to create is on the top of this plane that we had just created. So for that, again, I will activate my create a sketch tool. Then instead of selecting these three default planes, I will select this plane as a sketch plane. So since we are selecting this plane as a sketch plane, so we will be creating a sketch on that plane. Here you can see that plane we are just got activated for the sketching, and you will be able to see all the sketching tools, right? So now what kind of shape we are going to create onto the top? So definitely a shape that you can see right now onto your screen, where at the center we'll have a hole for our, there will be a manhole at the center. Then we have this four kind of flat portion like this. So this kind of shape we'll try to replicate, right? So for that, the first thing what we'll do, first we'll create a manhole, and the manhole diameter, just comment in the chat box, what is the standard manhole diameter that I had already explained to all of you. What is the standard manhole diameter for any kind of equipment? Just comment in the chat box. I'm waiting. Yes, 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 100% right, guys, 100% right. So we'll just activate my sketch dimension tool. We'll select this circle, and this circle we just want to make it 400 millimeters like this. There you can see. Now our next task is to create shape like this. There you can see, create a shape like this. So for that, what we can do, again, we'll activate our line tool. Here you can see we had activated our line tool, and I will start creating a, before that, what I will do, I will create a center line for the reference. So that will be easy for us, right? So I will activate my line tool. I will create a line from this point to this point like this. And again, I will press escape, again activate my line tool, and this time from this point to this point like this. There you can see. But as you can see, these lines are not attached to the origin. Here you can see I can move those lines. So what I can do here, I will apply the concept of constraints. So I will just activate my coincident constraint. I will select the origin and I will select the line. Here you can see the line just came onto the origin. We'll do the same on the other line. I will just drag it outside first. Then we'll activate the constraint. We'll select the point, and the line was already selected, so it came onto the point. And now I will just extend, since the length of these lines are not defined, so I can extend these lines uh, by any amount, since those are not constrained. So to make those lines constrained with the outer diameter of this circle, what we can do, we can use a constraint, again this constraint called coincident. So I will activate the constraint. This time I will select the perimeter of bigger circle and then this point, boom. Perimeter of bigger circle, then this point, boom. So you can see I'm just constraining my sketch, so it will be defined. So here you can see, since I had already constrained all the things onto my sketch, and if I will try to move any of the points by dragging with my cursor, it's not possible because everything is completely constrained inside the sketch. Now, what I'm going to do is I will just select these two lines by pressing shift on my keyboard. I can select multiple entities, and then I will change these two lines to construction line by activating this option over here. Now you can see those lines just changed to construction line. So there is a role of the construction line. Like construction line is like, it will not act as a very firm line that will separate your profile. It will just act as a reference line. So that is a benefit of having a construction line. Okay, so Joel is asking that, can you teach the first coincident step? It's very easy, Joel. For example, let's say if we have a line like this, here you can see we got a line like this. It's simple straight line. Now, if you want to make this point to be start from this point, so what you can do, just activate your coincident constraint inside the constraint panel. Just activate this coincident constraint, then select the first point, then select the second point, and the things will just come onto a single point. So that way you can do it. It's really easy, right? get back to our design. There you can see we had created. Now we are going to create another lines like this. There you can see I'm just creating another lines just to get the shape of the tank that we can see. So that's why I'm creating those lines. There you can see. Even if you had created a line like this, there you can see this line is not vertical, right? 100% vertical. It's on some angle. So how we can make it vertical? So just select your object or the entity, apply this constraint. It's called horizontal and vertical constraint. So this will make your line vertical. Here you can see. The moment I had clicked on the constraint after selecting my object, the constraint is being applied and the orientation of my line just got changed. There you can see we had just created a shape like this. Now we need to define the width of these things that we had created. For example, if you will just see onto your design, as you can see, these things are not very wide. These are just maybe 100 or 200 something like that. So that we are going to do. So I will just activate my dimension tool. From this line to this line, I just want to keep maybe 75 millimeters. So I will just change that to 75. There you can see. And again, on the other side, the same will do on the other side. So this one also 75, right? And now here is the small concept that you need to learn inside Fusion 360. So if I will just delete this dimension, let's delete it. And now if I will just hover over to my dimension, here you can see it says D6, right? It's the D6 diameter, D6 dimension. So whenever you're creating new dimension, instead of giving it by numbers, we can also write D6 over here. So it will automatically detect that dimension. Here you can see it says function of D6. So this means that this dimension is connected with this one. If I will just change that to 76, here you can see other is also updating. So this way you can make your design parametric also, like you can quickly make changes if you need. The same will do on the other side. Here also we'll define this one as D6. And we'll also do the same on this. Okay, we'll also do the same on this line and between this line. It's also D6. So all the 4 lines we had defined, and now if I'll see, there are 4 landings only. So that is really great. And also we'll create a line connecting like this. If you will refer on to your design, you will see that there are some landings like this as well. So these all things are just to give your design some extra strength. Here you can see I had created 4 landings like this, but these all 4 must be equal and on equal angle. So for that, what I will do, I will just select all 4 of them by pressing shift on my keyboard and will apply the equal constraint, and all of them just became equal now, but the length is different, the angle is different. So for that, what I will do, I will activate my sketch dimension tool. I will define the angle between 2 lines. Here, I just want to keep 45. And here also, I just want to keep. Okay, so I had to define it on the other side as well. Let's say 45. Or I got another idea, guys. Instead of defining all 4, what we can do, just delete the rest of the 3. Since we had already defined this one, here you can see this one is already defined. The only thing that we have to do is we have to define the length of this thing from here to here. Let's say I want to keep 200. Then I will just select one sketch entity. Then we'll go on to the create panel and got circular pattern option over here. So we'll activate that circular pattern. Then we'll select the center point, and then we'll specify the number of quantities, like how many times I want to pattern. So here you can see it's giving me a preview for number of times. I will press OK, and this is what we got, right? Now let's move on to designing our other parts that we can see onto our design. So I will click on the finish sketch. If I will just orbit it, I can see something like this. Now what I will do, I will just activate the extrude tool option from over here. Then we'll select the complete profile. This is the profile that I wanted to extrude, that you can see right now I am selecting. So if I will show you from the top view, this is the profile that I am selecting. So since those all were firm lines, solid lines, that's why all the profiles were separate. So I had to select them all one by one. So I had selected all the profiles, and then I will inside this extrude panel option over here, you can see extend. I will just write up to object, and then I will select the object. And here you can see it's extruding up to the object, right? It's extruding up to your object. So I will just press OK, and here you can see this is what we had created. Now the next thing is that we had to create this curve portion over here. Here you can see onto the top. So this is what we're going to create now. So for that, what I will do, I will again click on this create sketch option over here. We'll go on to the front panel. Here you can see front view. Now here what I'm going to do is I will just activate we'll go on to the arc tool. I will activate my 3-point arc, and from this point, from the outer edge and to the center, I will create an arc like this. There you can see. So I will make sure that this arc is we are tangent to the arc. So for that, what I will do, I will create a line from the origin, something like this. And if you will remember the height, the total height that we had considered, the total height was, if you'll just go on to here, the total height was 1225, right? So I will just give it a height of 1225 or a little bit lesser, maybe 25 millimeter less. So I will just write 1200. Here you can see. And onto this direction, I will just connect from here to here onto this line, and the diameter I just want to keep 550, if you remember. And here you can see. Now the base height, if you will remember the effective height, I mean up to the flat portion. So that height that we had considered was 1050. So this one I will just give 1050. Here you can. And one more thing, one last thing, I will create a line from the top over here, a horizontal line, something like that. So again, if you're not sure your line is horizontal, just create the line, select that line, apply the constraint. So it will become horizontal. Again, I don't need this line as a solid line. So I will select the line. I will convert that to construction. Here you can. So it's really easy, right? Inside Fusion 360, it's really easy. So here guys, I had a small problem over here. So if you will just remember the center, we had created a manhole of 400 millimeter diameter. So instead of starting my arc from this point, so I will delete this arc. I will create an offset line from this point of 200 millimeter. Here you can see 200 millimeter. I had created another offset line, and from this point, I will create an arc like this. Okay, not line guys, sorry. I will just go into the panel and will activate my 3-point arc. Then we'll select the first point as this point, the second point as this point, and an arc like this. Here you can. Now we got something, right? Now we'll just click on the finish sketch. And here you can see we had created some profile over here. If I will just turn off the body, here you can see this is the profile that we had created. So I will activate my Revolve tool. I will select, the profile is already selected, but if it's not selected, you can just click inside anywhere inside your profile and it will get selected. Now the center of axis is definitely this axis. So I will click on this axis. I will turn on the body, and instead of cut, I will make operation as join. Here you can see. The moment I will click on this join option over here, and if I will press OK, so we got a shape of our water tank. So if you will see onto the design, original design, so we are getting something like that. But in our design, it's looking like we had to increase the width of these things a little bit. So that we can also do, like we can make quick changes to our product design process using Fusion 360. And that we can do using this design timeline that you can see on the bottom. So just come back to your sketch that you had created. So this was the sketch that we had created for these areas. So I will just click on this sketch. We'll make a right click and we'll click on the edit sketch. Here you can see. So I just need to change the single dimension, and since all the dimensions are connected, will get updated. So here I will just change that to maybe 100. And then I will press finish sketch. Here you can see the things just got updated. Now it is looking very good. It is very correct now, right? Now, since we had created this, the next thing that we had to create ribs on these faces, right? So these ribs, these ring kind of shape that you can see onto these faces. So that we had to create right now. So for that, we'll again apply the same process, like we'll create a sketch and we'll revolve it around our object. Since it's not a circular ring that are a customized profile, so that you will see right now. So again, activate your create sketch tool, select front plane as a sketch plane. Here you can see. Now, what I will do, I will go on to the inspect panel and I will activate this section analysis tool. and I will select this front plane as the cut plane. And here you can see. Now I am seeing the section view of my tank. So if I will press OK, and if I will just check onto the design, original design, there are 4 profiles, right? 4 profiles equally distributed along the complete this phase. So I will just go on and start creating those profiles. So the profile is, guys, something like this. If you will see my sketch, the profile is something like this, that is revolving around your tank. There you can see the profile is something like this. And again, I will connect those profiles like this. And now this line is not completely vertical. So I will select this line, will change that to vertical. Now I will start defining these things. For example, let's say this area, the ring width of the ring is 30 millimeter, right? The extension of this ring is maybe 10 millimeter will be enough, or maybe 15 will be enough, something like that. And then the top and the bottom angles are equal. So I will select both of them, will apply the equal constraint, and then we'll define the angle also. So this angle, I believe is let me check if it's already defined. So it's already defined, guys. So we cannot change it further. Anyway, so if I will just change the diameter for this one. So diameter is from this point to the origin. This is 550, all the time 550, because we are just following standard. Now, if since we need 4 number of times up to the height of 1050, right? So we need this 4 number of times. So what I will do, the first position I will define from the bottom. So I will activate my dimension tool. I will activate my dimension tool, will select the origin and the bottom of this thing. And this one, let's say 100. And here also we'll change this to 550, not 560, 550. Now it's touching to our tank. And then I will select this complete profile. So how you can select the complete sketch? Just double click on any of your closed sketch profile and it will select the complete loop. So that are all shortcuts that you can use in Fusion 360. And since I had selected the complete sketch, I will go on to the create panel. We'll activate this rectangular pattern. There you can see. Now I will drag this arrow that you can see onto the top towards this direction, and will change the quantity to 4 number of times, and we'll drag it up to the height like this, right? There you can see. So it's what it is doing. It's since we had left 100 millimeter of space on the bottom, the same will leave on the top as well. So if it's 1050 and we are leaving 100 millimeter on the top and 100 millimeter on the bottom, so that will come around 850 left, and inside 850 we had distributed 4 number of times. So it's correct. So I will just press OK. And now if I will just turn off my analysis, there you can see this is what we got, right? These 4 profiles. So now what I will do, I will just check the reference sketches. So now it's not good. You can see there are more spaces on the top and on the bottom. So I had to change. I will change that to 150 maybe. And also I will change the pattern. So I will just click on this pattern symbol. And here I don't want to cover 850, maybe 750 will be enough, and we'll press OK. So we'll try to see if it's looking good. So now it's again not looking good. So we'll change that to maybe 650. So that will be good. So yeah, 650 good, guys. So now what I will do, I will click on the finish the sketch. I will activate my revolve tool. Will select all the 4 profiles to revolve, right? And for the axis, I will select this green line, but I cannot select that green line since the body is coming onto the front. So I will just turn off my body. Then I will select the green line. Then I will turn on the body. There you can see. We are getting those profiles revolved around the parameter. And operation is join. Make sure that you had considered the operation at join over here. This means that whatever the new profiles that you had added is getting added with your base body. So I will press OK. And it will take few seconds. And here you can see this is what we got. Now all the things are very sharp. All the corners are very sharp, right? We had to apply some fillet onto these corners. We want to make some smooth curve onto these corners. So for that, we got a fillet tool. We'll activate that. We'll select all the sharp corners one by one like this. Here you can see. There are some quick ways to do that, to select all these profiles, but we're not going to learn that. But you can select one by one all the 4 corners. There you can see I had selected. Then we'll give it a fillet of maybe 0.1 millimeter or something like that. So you can see those are getting smooth. I think 1 millimeter is very less. So maybe we have to make it 10. 10 is very high. Maybe 5 will be good. Yes, 5 is very good. I will just press OK. Also, the bottom of the tank, if you will see, it's not very sharp. It is also smooth out, right? So someone is asking, I can see someone is asking a question that, sir, can you please repeat how to decide the spacing between the ribs? So Tathagat, the spacing is all about like based on the visualization. Since we had not a very defined spaces defined over here onto the syntax website, so we are considering those spacing. So what we did, we had taken a 150 millimeter from the bottom. So the first rib that we are starting is from the bottom is 150 millimeter. Then we had taken 4 ribs and we had equally spaced all those 4 ribs inside 650 millimeter. So if you will just go and we'll go back to the sketch, here you can see we had taken a space from the bottom rib. The space is 150 millimeter. And if I will just double click on the pattern to see the pattern dimensions, so here you can see we are covering total distance that is 650 millimeter. This means from this tip to this top tip. So this is total 650 millimeter, and inside 650 millimeter we had confirmed the quantity as 4. So Fusion 360 has automatically divided all the spaces based on the total distance that we had provided. If I will provide 651, Fusion 360 will automatically divide the spacing and will give us a result, right? So this is how we had created. I think I had answered your question. I will just click on the finish sketch and go back to our model. So we'll activate the fillet tool again. We'll select the bottom corner, and here I will just space of maybe 10 millimeter. Here you can see. So the 10 is very less. So maybe I want to give more kind of fillet, maybe 25. I think is going to work very well. So I had just given 25. Now it is looking good. Here you can see. Now, since we are done with the outer part of our tank, now let's move on to creating the top opening for the manhole. Here you can see. So I will just click on this top face. We'll click on create a sketch. Here you can see. Now I will just activate the sketch that we had created earlier for the manhole. Here you can see this was the sketch. So I'm going to project that sketch that we had created onto this top face. So for that, what I will do, I will go onto the create panel. I will click on this project tool. So if you are using SolidWorks software, that tool is considered as a convert to or something like that kind of tool. So if you have the exact name of the tool, just comment in the chat box. So I will just activate this project tool. I will select this profile and will press OK. So that profile just got projected to our onto our new sketch. Here you can see. If I will just turn off the old sketch, this is the sketch that we had just projected. Now I will activate my offset tool. I will activate offset tool and will offset it by maybe 20 millimeter or maybe 10 millimeter. Here you can see I just offset it by 10 millimeter. Then I will click on the finish sketch. And now what I'm going to do is I'm going to create a small throat, or you can see a space where the cover will sit or something like that. So this I'm going to create. So I will just create a 20 millimeter and will press OK. There you can see. Now this tank is right now, if I will show you the projection view, section view, sorry. So you can see the tank is not, the tank is not hollow at this moment. It's completely solid. So what I can do, I will just try to make it hollow from inside. And the thickness for such kind of tanks are 20 millimeters or 25 millimeters, like that. So we have to consider that. So before that, what I will do, I will change this offset distance to 25. If we are going to, or maybe 15 millimeter, we are going to take a thickness of this tank as a 15 millimeter. Since I had checked their website and I had found that the thickness for those tanks are 15 millimeter. It's vary based on the volume of the tank. For example, if you are taking a 1,000 liter tank, the thickness is different. If you are taking a 500 liter tank, the thickness is different. But for this design, I'm going to take a thickness of 15 millimeter. So to create this complete solid design as a hollow design, I will use this tool called cell tool that you can see over here. So I will just activate this tool. We'll select the face that I want to remove, and then I will specify the thickness. So let's say 15 millimeter. So the moment I had clicked on 15 millimeter, here you can see our tank just got hollowed, right, by 15 millimeter. And if I will press OK, here you can see we got a tank with a hollow shape of 50 millimeter, 15 millimeter. And now if I will show you the section view, I will activate my section view, and here you can see this is my tank piece. This is the water tank that we had designed inside Fusion 360 in just maybe 30 or 40 minutes, right? It was easy. Maybe if you had the manufacturing plant to design this part as a molded product, you can do that. But this is what we had created in just 45 minutes, I will say, using Fusion 360. Very nice. Now, this is the design we got. Now, if you want to put any kind of branding or anything, you can just put that because we got an option inside Fusion 360 to insert canvas. So canvas is, insert decals. So decals is like you can put your logo or something onto your design or anything. So I'm going to put a small logo onto this tank. So let's do that. We'll go onto the insert portion over here. We'll go onto the decals option, and I'm going to take that from my computer. So I will just go on and check if I can find my logo. Here it is, guys. Let's take this PNG logo and we'll click on open. Then I have to select the space where I want to put my logo. So this is the face, and here you can see it's getting projected, right? It's getting projected. So I will just adjust the orientation. I will adjust the scale. I will adjust its position, right? Something like that, maybe a little bit lower or something like that, or maybe not here, maybe here, or maybe on this direction, and we'll press OK. So here you can see this is the logo that we had just kept onto the our tank, right? So this way you can start designing. And also if you want to change the material, like I don't want the color of this tank as this something kind of gray. I just want this to be look more beautiful. So I will go on to the modify panel, we'll go on to the appearances, and then a new window will pop up where I can search for the material. For example, let's say blue plastic, right? Blue plastic. And if I will just go down here, you can see the Fusion 360 materials library is giving me some options. Like if I want to use this glossy material, I can just drag it and apply onto my object. There you can see. It is fast, right? I can drag it and apply into my object, and the appearance of my object will change instantly. So this kind of designs you can do inside Fusion 360.